Hey guys, I wanted to give you a brief introduction to the other kind of compound that we mentioned at the beginning of this unit, which is covalent compounds. Everything that we've talked about up until this point is about ions, ionic compounds. So we talked about um, coming up with formulas by looking at charges for ionic compounds. But let's just a quick reminder of what's the difference between an ionic and a covalent compound. So an ionic compound is when we have two differently charged atoms attracting each other. So you always have a positive and a negative attracting. Covalent compounds are sort of an entirely different branch of compounds where instead of gaining and losing electrons to make ions, they're sharing electrons. And so there's a reason this happened, but everybody keeps their electrons basically. And so they're sharing electrons in order to get a full set of 8. They share to complete an octet, as we say. So this is where we see the word covalent. So co meaning together, and valent meaning valence electrons. So covalent compounds, as we said, have to do with sharing electrons. And this happens when two atoms share a pair of electrons. Remember when we drew our Lewis dots, or our Bohr model, where we put all the electrons on there as dots together? We said it was a little bit easier to do if we kind of paired them up, right? Like if we and there's a reason we did that. It's because it's easier to see the pairs, but also because when electrons are shared, they share in pairs as well. This only happens with a certain kind of element. It only happens with nonmetals. So as a reminder, where are the nonmetals? The nonmetals are off to the right side of your periodic table. So anything to the right of the staircase is a nonmetal. And sometimes hydrogen is considered a nonmetal as well. So usually we consider hydrogen as capable of sharing electrons. Even though it has a charge written there, it can become an ion, a positive ion, but normally we consider hydrogen to be acting like a nonmetal in this circumstance. So hydrogen can share electrons as well. So when this happens, what we form is called a molecule. So we haven't actually talked about molecules yet because molecules can only occur if atoms are sharing electrons with covalent bonds. The other type of structure we talked about already was with ionic compounds. So we talked about the idea of positives and negatives kind of sticking together in a giant network. That's not a molecule. That's something else. That's called a lattice. A lattice is what's created when you have a giant network of positives and negatives together. But what happens when electrons are shared is that you have these individual bonds and you just have a much smaller group of atoms. And that's what a molecule is. This is not a molecule. This is a lattice of ionic compounds. So this would be an example. Water is a great example of an ionic or of a covalent compound, where you kind of recognize this. So there's oxygen in the middle and two hydrogen atoms bonded to share electrons here. So something that's worth mentioning about this is that we've talked about how we can't see an atom because atoms are much smaller than any particle that we can look at. But we actually can see, we have gotten images of molecules before. A molecule is much larger than one atom. So some very large molecules have had images captured. This was one that IBM did in the early 2000s. The molecule is called pentacene, because it's got 5 rings of carbon atoms. This is much, much larger than just one individual atom, and they did it by running a very sharp point made of another small molecule over the molecule and sort of feeling it like you would feel for braille dots. If you couldn't see, you would sort of feel for what the shape was. So they just had a small device that did this. So there's a video describing, if you want to go to this link, there's a video describing how they did that. But we can actually do have images of molecules, so we know a little bit more about their structure than we do individual atoms, visually anyways. So the question is, how can you tell if a compound is going to be an ionic compound or a covalent compound? And the key comes down to what elements are there. So ionic compounds always have to have a positive part and a negative part. There are always two words. They're always something "-ide" or something "-ate" because you have a positive and a negative. So ionic compounds always have to have a metal and a nonmetal. So looking at the periodic table, they always have to have something from the left side of the staircase and something from the right side of the staircase, because they have to have something that represents a positive and something that represents a negative. But covalent compounds are only nonmetals. So when we're looking for covalent compounds, we only have to look at the right side of the staircase to find those. So the only thing I want you to be able to do at this point is to be able to just spot them. Now the naming is a little bit goofy for covalent compounds, which I'll show you in our next lesson. But I really just want you to look for the element names or the element symbols and see if you can sort of make it out. Okay, so here's a list of some compounds. Some of them are ionic and some of them are covalent. So I want you to be able to tell me which ones are which. Sodium chloride, if I look at my periodic table, sodium is a metal, chlorine is a nonmetal. So that means that sodium chloride has got to be a ionic compound. Why did my slides got out of order here? So sodium chloride has a metal and a nonmetal, so that is a ionic compound. FeBr3, iron is a metal and bromine is a nonmetal. So iron's a metal, bromine's a nonmetal, so that's also ionic. CO, this might look like cobalt, but actually we have two capital letters here. So this is carbon and oxygen. We call this carbon monoxide. So this is actually two nonmetals, so this is covalent. Nitrogen triphosphide. Nitrogen is a nonmetal, and triphosphide, what's triphosphide? Well, we see phosphide here. Phosphide is phosphorus, so nitrogen and phosphorus, so those are both nonmetals, so that's also covalent. Calcium is a metal, nitrate is a nonmetal ion, so that's going to be ionic again. Fluorine monochloride, so fluorine and chlorine. So mono, again, we see in there. Mono isn't an element, it's just a prefix, but we can see chloride is chlorine. So those are both nonmetals, so that's going to be covalent. Okay. I want you to be able to distinguish between the two of those in the assignment that I give you.